Hello all, welcome to the iitiansgateclasses classes. So in this particular demo series, we're gonna start strength of material, and one by one we are going to cover the 10 topics that is the main topic of the strength of material in a sequential manner, so that you can cover each and every topic and understand basic fundamental of subject, right? So now we will start with the normal stress and strain. That is what we are starting here. So here basically, if I talk about the stress, it is describes basically the intensity of the internal force acting on a specific plane passing through a point. That means we know that I can tell you that stress meaning is that it is the internal force developed at a particular point for the material, right? So at a particular point, let's suppose we have the material or we have the bar which is fixed at one end, and we are applying some kind of force, that is a tensile force. When we apply the tensile force at a particular point, let's suppose AB, there is a one plane, there is other plane CD, right? So we have many planes at a particular point. So specifically we require the basically we need to define one point, as well as we need to define the plane also for defining the stress, right? So here what we can call, suppose we are applying any force to the member like this. We are applying any force. So when we are applying any force, let's say this is a tensile force which is moving away from the cross sections, right? If I just show you the cross section, let's say a very thin bar, which is a rectangular bar, which is being subjected to tensile force. So this is what my cross sectional area, right? I can just give any name, that is B into T. That will be my cross sectional area. So here what I can write, my dear friend, if I cut the member at a section XX, so what I can see, if I draw the free body diagram of this right side, not the left part, only the right side portion of the bar. If I just show the basically the free body diagram. So here we are applying the force P, and because every material wants to be under rest condition, initially there was no disturbance to the material before application of the load. So what the body or what the Newton's first law is saying, that whatever the molecular gap at a particular temperature will be there for whatever the molecular gap within the material, that will remain same. They want to maintain the same gap between the molecules, but you are trying to apply the force P, you are trying to disturb the molecular stability of the whatever the molecules of the particular material. Let's suppose we have the molecules here, two molecules I'm just considering, alpha and beta, let's suppose, and they have the bonding between them, alpha and beta. Some bonding is there. That bonding length you are trying to change by deforming the by the application of the load, right? So in this strength of material, we will talk about the deformable bodies which can deform. But in the engineering mechanics, we talked about the non-deformable bodies. We say that it's a rigid body, right? So that is the first clarity about the difference between engineering mechanics and strength of material. Now, if I draw the the free body diagram of this section, so there will be some kind of internal resistant force will be developed. Let me call this to be R. What is the R? Internal force. Internal resisting force. Why the material will develop any kind of internal resistant force? Because they want to maintain their original state of stress conditions, but you are trying to applying the force P, and you are trying to disturbing the initial state of a body, right? So they will definitely oppose that particular deformations, and in that doing so, they will be developing some kind of internal resistant forces. So if I just do apply the equilibrium equation of engineering mechanics, summation of forces in the horizontal direction will be 0. So P will be equal to what? R. And because P is equal to R, we say that sigma, that is nothing but stress. Stress is defined as internal resistant force per unit area, whatever the area is there. But my dear friend, here R is equal to P, that's why we are saying what? P by A. Or in the limit, when delta A tends to 0, we say P by A, because when delta A or whatever the area tends to 0, it will become a point, and stress is defined for a particular point. Without specifying the point, there is no meaning of defining any kind of stress, right? Now, so this is a very basic fundamental that we are developing right now. So here, my dear friend, you will be understanding that sigma is nothing but what? P by area. So that is the concept of stress. Now, the next concept will be stress is what? A tensor quantity, but it is a second order tensor. Why we are calling this to be a second order tensor? Because to define the stress, we require the not only magnitude, we require the direction as well as plane. On which plane? See, at a particular point, we have lot many planes. So we need to define on which plane actually you are talking about that stress value has been developed, right? So first of all, magnitude as well as directions as well as planes. So we define by sigma ij, where I is nothing but what? I is nothing but indication of the plane on which it is act, or sometimes we say that it is nothing but phase on which it is act. J means nothing but what? Direction, in which direction it is going to be acting. Let me give an example, a very simple example that, so that you will be understanding. So this is X, this is Y, and this is Z. So my dear friend, if I apply this sigma over here, first of all, what is this? See, any plane is there. This plane is what? This plane is YZ plane. This plane is YZ plane, right? There's no doubt in that. But this YZ plane, what is the outward normal? Outward normal is X-axis. So we say that X phase. So what you can write? Sigma X, because this particular value of the stress is acting on X phase. In which direction? X direction. Or if I just say something like here also, one tau, which is being acting. And if I say it is acting on X phase, in which direction? In Y direction, something like that. Now you come to know stress is basically what? Two types, right? One is a normal stress, which is acting perpendicular to the area. And second one will be shear stress. Again, shear stress will be two types. One is a direct shear stress, and second one will be torsional shear stress, right? So very first thing is that the normal stress, right? The normal stress means whatever you are looking right now into that picture, that is this particular figure. Sigma xx. Shear stress will be tau xy, which are acting what? The stress because the force is acting parallel to the area, right? If I consider this particular area, so for this particular area, tau xy is a parallel one, and sigma xx is what? It is a normal to that particular area, right? So these are the things, that is a notation, which quantity it is, and the definitions, right? So we have covered these things, So see, the direction will be, if I just talked about the sign conventions, if I just say about the sign convention, my dear friend, if you are considering the body or material, if the load is going away from the section, sigma, something like this, we say that this sigma xx, this sigma will be positive sigma xx. If it is coming towards the cross section, if it is coming towards the cross sections, for this one we say, let's suppose sigma x dash, it is sigma x dash, then we say that it is nothing but minus of sigma. Sigma will be minus of sigma xx. It is coming towards the cross section, right? Now, what about the distributions? Always whenever the tensile load will be applied, pure tensile load exactly at the centroid. Remember, whatever the formula we have discussed, if I just find the centroid of this particular section, at the exactly the centroid, if I apply the force P, exactly at the centroid, if I apply the force P, my dear friend, there will be normal stress P by area, but it is only valid for when it is only valid, when load is acting at exactly at the centroid. Exactly at the centroid, right? So these are the things that we have covered, and you can see that distribution will be what? Uniform distribution. That means if I apply any amount of load, and let's suppose because of the P, there will be some sigma will be developing P by area, and what is the distribution? Distribution will be something like this. There will be uniform, stress distributions. there will be uniform stress distributions, right? So these are the things that is very, very important. Now, so we have talked about the stress. Now we will talk about the, the concept of principal stress, right? So now, my dear friend, let's see about the principal stress, right? So now, before understanding the concept of principal stress, I would like to tell you the why we are studying the topic of principal stress, right? So yeah, let me tell you the physical significance of studying the principal stress. We have talked about the stress. You know the meaning of stress, that whatever the force we are applying, because of the force, there will be some internal resistant force will be developed in the material on a particular cross-sectional area. That ratio only we are calling what? The ratio of the load per unit area, or the load area ratio, we are calling what? Stress. Not exactly the load, external load. Remember that in strength of material, we are only talking about the internal resistant force. If internal resistant force will be zero, there will no stress. There will not be any stress. Even though you apply the external load, if the material is not responding to that particular load, then stress will be zero. Right? Now, try understanding what is the meaning of principal stress. So when you take the material, let's suppose you have the material circular bar, which is being applied the load P. There is a one circular bar, right? There is a circular bar of the diameter D, and which is having a length L, and we are applying some kind of tensile load, right? If I'll be asking you what is the maximum normal stress, what is the maximum normal stress? So you will be telling me P by A, or 4P divided by pi d square, right? Directly area is nothing but what? Pi by 4d square. So you're gonna tell me that whatever the forces we are applying, that is nothing but producing the normal stress. That is the maximum normal stress. If at this point of time, if I'll be asking you one question, what is the shear stress on plane AB? My second question is, what is shear stress what is the shear stress on or in the bar, in the member, in the circular member? So there's a two question which I kept right now. You can see very clearly. If I'll be saying that shear stress on a particular plane AB, right? So for the first question, if I'll be asking you shear stress on a plane AB, for defining the value of the stress on the plane AB, I need the value of the force P, which are parallel to the AB. But there's a no force which are parallel to the AB. There's a no such kind of force. This PS is zero. If PS will be zero, my dear friend, the force is zero. Even though we have the area, the stress value will be zero. So basic SOM equation, remember that basic strength of material equations will give the sigma n, normal stress, and tau s value on a particular cross section, right? So if I'll be talking about the second question, what is the shear stress in this circular member? That is not equal to zero. That is not equal to zero, my dear friend. On the plane AB is zero, but I told you stress is defined at a particular point. At a particular point, not only plane AB is passing, we can define any plane. We can define this plane also. We can define this plane also. We can define this plane also. Any plane, at a particular point, we can have infinite planes, right? So there might be some chances that on the plane AB, the shear stress is zero, but not onto the some other planes. There may be some kind of value of the shear stress might be acting on a particular plane, right? So in that scenario, my dear friend, remember that one thing we need to understand, for that purpose only, on a particular plane, if I want to find what is the value of the shear stress onto this plane, for that only we are defining principal stress or principal strain chapter, right? One more reason is there, physical significance, if I'll talk about. We have the two types of material. One is ductile material and other is what? Brittle material. Ductile materials are very, very weak in shear. So definitely they're going to fail by maximum shear stress, right? If suppose this is a ductile material, if suppose this is a ductile material, and if I apply the load P, and if you say that the shear stress will be zero because there's no force P which are acting parallel to the area. You are saying about the plane AB, right? That means if you are saying that there is a no shear stress, indirectly you are saying that the material which is available right now in front of us will never gonna fail. But it is not like that. We have seen that when the amount of load which exceeding the some certain permitted limit of a limited value of the load, then we see that the material is what? Failing, right? We see that the material is what? Failing. Now, further, my different, what we can understand. So for basically, we want to find what is the maximum shear stress developing in the material at a particular plane passing through a point. What is the maximum value of the shear stress, so that we can come to know what is the amount of maximum shear stress is acting, so that we can save the material before itself. We don't apply that particular touching, crossing limit or limited value of the load, which causing that maximum tau max, right? If I will be able to find this tau s theta, which is x megapascal, then I can save the material. I will be just giving some more amount of dimension to the material, so that the next time, next cycle, it is not gonna fail. I will be applying less amount of load, right? So these are the factors of safety we're gonna consider when we know what is the maximum shear stress. Similarly, brittle materials are very, very weak in tensor. If you know what is the maximum normal stress for the brittle material, you can save the material before failing itself. So those are the physical significance that we must understand before understanding the formulas and all the concepts. So one thing is sure, the sure shot guarantees that the strength of material will giving you this P by A onto the particular cross-sectional area. On a cross-sectional area on the plane AB, strength of material giving me the values of the what? Formula. But it is never going to give me the value at a particular plane which is inclined at an angle theta from vertical. Let's suppose, just for the sake of understanding, we are assuming that it is defined, it is just inclined at an angle theta from the vertical, that plane CD, this plane CD, right? So these are the circumstances before starting what? Principal stress. Let's see, let's analyze and let's find what is the normal stress which are acting on a plane, and what is the shear stress acting on a plane which is inclined at an angle theta. For this, my friend, let me just take you to this particular determination of the stresses on an inclined plane. Determination of stresses on an inclined plane. For that purpose, for this particular understanding the development of this particular topic, what we are taking, we are just saying that material is there. I'm just taking one material, right? See, there might be some load is there. Suppose a material is there which is being subjected to different kinds of load, P, twisting, in basically upcoming whatever the demo series will be there, demo lecture series will be there, you will come to know each and every loading conditions. But for the time being, my friend, I'm just saying that suppose we are applying the normal load, we are applying the twisting load, we are applying the bending moment also. Let's suppose after complex state of stress conditions, let's say the material I'm just considering any point on the top fiber, and let's say I'm just zooming it out, and I'm just analyzing that it is subjected to sigma y, sigma x, right? Sigma x, and it is being subjected to shear stress. I told you, because there is a twisting is acting. When twisting is there, definitely shear stress will be developing. That we call torsional shear stress. This is my state of stress, or we are calling this to be complex state of stress. Complex state of stress. My dear friend, I need to find, in this particular element, I need to find what is the normal stress on a plane AB, which is defined at an angle theta, and what is the shear stress value. What is the normal stress and what is the shear stress? That is what we need to find, my dear friend, right? And we can very easily, we can find, there's no doubt in that. How we can find? That is again, we are going to use the concept of engineering mechanics. That is what? See, we are going to consider only this part of the element under equilibrium conditions. What is the meaning of equilibrium conditions? Summation of forces in the x direction 0, summation of forces in the y direction is 0, summation of movement about any point has to be 0, or you can also do that in the normal directions or tangential directions. You can just equate summation of forces in the tangential direction is equal to 0, summation of forces in the normal direction is equal to 0. By using this engineering mechanics concept, you can develop the formula for the stress value at an angle on a plane which is defined at an angle theta from the vertical, right? So we are having the sigma m and tau s theta. How we can find? That's a very simple. Just you should know the fundamental of engineering mechanics. You can prove very easily, right? Remember, summation of forces has to be equated to 0, not summation of stresses. Now, and we are taking this particular element. When we are taking this particular element, that means we are considering that this particular part of the element is what? Under the static equilibrium. If this is under a static equilibrium, whole body will be under a static equilibrium. That is a very fundamental concept of engineering mechanics, right? So by doing so, you can develop some relations. So these are the important formulas that you should note down. Equation number 1, equation number 2. In our detail, basically, when the course will start, we will be covering beautifully about each and every topic. But for the sake of time being, whatever the time has been allotted for this demo series, in that particular time constraints, we're gonna see the overall view so that you can understand before starting the actual series, right? So that is one, basically kind of a reason for you, right? And that is only the good thing. So now, if I just say, my dear friend, these are the normal stress, these are the shear stress, which are acting on a particular plane, which is defined at an angle theta from the vertical, right? So now, what is that formula? This formula which we have noted down, whatever the formula you have just seen, that sigma and theta, that is sigma x cos square theta plus sigma y sin square theta plus tau xy sin 2 theta. When you use the trigonometric equations, when you will use the trigonometric, that is, 2 cos square theta minus 1, that is cos 2 theta, 1 minus 2 sin square theta, that is nothing but sin 2 theta. By using that, we can further simplify this equation to our very basic equation, that sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy into sin 2 theta. Similarly, tau s theta, we can write sigma x minus sigma y by 2 sin 2 theta minus tau xy into cos 2 theta. So these are the two important formulas that we must able to remember for understanding. And remember, what is the sign convention we have considered for this? A plane which is inclined at an angle theta, or we can say that axis passing through this plane. Which plane? Let me just call AB plane. It is making an angle theta from the horizontal. See, remember, there is a two-way to define a plane. A plane can basically make an angle theta from the vertical, or axis passing through the plane. Whatever the axis is there, that passing through the plane AB is defined at an angle theta from the horizontal. Clear? From the positive x-axis, whatever the theta is there, that axis is making. There's a two-way. And what is the sign convention for the normal stress? If it is going away from the plane, that we define that it is a positive value. If the answer is coming out to be positive, that means like this. If this particular answer is coming out to be positive, that means it is acting in the downward directions. If it is coming as positive, this will be basically what? The diagram. That will be the rotation of that will be the direction of the arrow, right? So these are the things that is a very, very important, and of course we have considered sigma x here, sigma y, which is away from that. And we have also covered that tau xy. What is the sign convention for tau xy? If you just look at the diagram, tau xy has to be acting like this. Then only it is considered as positive. Right? something like this. Now, before starting the whatever the previous year question of the gate examinations, few more thing I would like to add here. See, we will define the principal stress and the principal plane. As of now, you have just seen that whatever the value of the plane, whatever the value of the normal stress which are acting on a plane, and whatever the value of the shear stress which are there, right, that particular plane is considering both normal stress and shear stress. But sometimes there is a plane, sometime there might be one plane which define at an angle theta on which we have only normal stress, there will not be any shear stress. There's a one kind of plane A dash B dash where we have only normal stress, we don't have any kind of shear stress. That plane will be called as principal plane. And whatever the value of the normal stress you are looking right now, that will be called as principal stress. That will be called as principal stress. How to find that? It's very easy. It's very easy. Whatever the formula you have seen, sigma and theta, whatever the formula you might have seen, that is sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy into sin 2 theta. This particular formula you have seen that you simply differentiate and equate to 0. From the mathematics, what is the maximum value? See, if you have the function y is a function of x, y is a function of x, right? And if you want to find what is the maximum value of the y, what you do? Dy by dx equal to 0. Same thing. D sigma n divided by d theta, we have to equate to 0. When you equate to 0, you will be getting what? Tan 2 theta. You will be getting two values. One is theta p1, other is theta p2. And both should be what? Making an angle what? 90 degree. Whatever the difference is there, theta p1 minus theta p2, they should make a degree what? 90 degree with each other, right? What is the meaning of that? See, if suppose one plane is there, you are just applying the force like this, like this, like this, and you have the tau xy. Now, my dear friend, understand, there will be one plane and there will be another plane, let's suppose, right? So here we have the, let's suppose sigma 1, here we have the sigma 2. What is the angle? One is what? Theta p1, other is what? Theta p2. What is the difference of this angle? What is the angle? We have the 90 degree with each other, right? Both the planes will make the angle what? 90 degree, right? If suppose theta p1 will be, suppose we have the 50 degree, theta p2 will be what? Obviously 40 degree. Together, they will be making the angle what? 90 degree with each other, right? So here we can just have a look. Theta p1 plus theta p2, this together the angle will be what? 90 degree, right? We can find any other values of theta p2. Let's suppose theta p1, we know that. Theta p2 we can able to find 90 minus theta p1, something like that. Getting my point? So these are the fundamental concept of principal stress and strains, right? Now, so next thing what we can understand, of course, one precaution here we must understand while defining the plane, of course, we're gonna see the question also. Do not worry about the, those things. Suppose theta p1 we are writing positive, that means if we are getting positive means angle is what? Anti-clockwise. This angle is what? Anti-clockwise. Suppose it is coming out to be negative. See, here you are defining with respect to what? Positive, right? Minus 40 degree. It will be what? Minus 40 degree, right? So it is basically, depends on what is the value you are getting, two values, right? By using this particular formula, what value you are getting, based on that, this particular will change, right? So theta plus minus we can write. So that will be a better way of writing that, or I can do that. We can remove this part. When we see the numerical, then you can understand the concept of angles, right? Now, so what is the value of the maximum shear stress? Sometime, my dear friend, we want to find what is the value of the maximum shear stress. So for that purpose, what we have to do? Tau s theta, whatever the formula we have, sigma x minus sigma y by 2 sin 2 theta minus tau xy into cos 2 theta. So this formula we have to equate to 0. This we have to equate to 0. While equating to 0, you'll be getting this particular formula. So these are the, again we're gonna get the two values. One is what? One value will be theta s1, other will be what? Theta s2. That means it is the value of the maximum in plane shear stress, right? The locations of the maximum shear stress. Two value you wanna get it out. You know, from the trigonometric we know that when we take the tan inverse, two values we're gonna get it out, right? Now, so these are the formulas that we have developed, right? Let's see the problem that is being asked in, in the great previous year papers. And while solving the previous year problems, we can understand the whatever the formula we have, learned actually. So when you just look at this particular problem, what you can understand, a state of stress conditions they have shown, what is the orientation of the plane with the maximum shear stress with respect to x-axis they are asking, right? And just now recently only we have seen one formula, right? Just now only we have seen one formula for maximum shear stress. For the maximum shear stress, my dear friend, tan 2 theta is what? 2 tau x, sorry, we have the formula, what? Sigma x, sigma y minus sigma x divided by 2 tau xy. This is what the formula we have. When you remember that, tan 2 theta, sigma y minus sigma x divided by what? 2 tau xy. This is the what? Value of the for the maximum shear stress planes. We have to what? Do these particular things. Now put that value. According to our sign convention, sigma x has to be like this, but it is coming towards that means negative. Sigma yy is what? It has to be towards away from the cross section, that is positive, but it is coming towards, again it is going to be negative. Again it is going to be negative. What about tau xy? According to our sign conventions, we have defined that tau xy should be like this. Then already is positive tau xy, right? But in this particular figure, whatever the things they have shown, that is not exactly according to our sign conventions. It has to be negative 30 megapascal. So when you put into this particular formula, sigma y is what? Minus 20 plus 80 divided by what? 2 minus 30. So when you just put the values and 60 divided by minus 60, you'll be getting what? Minus 1. So when you just take the tan 2 theta, you are getting what? Minus 1. And when you just take 2 theta, that is tan inverse of minus 1. How many values are you gonna get it out? You're gonna get it out two values. One is theta s1, other is what? Theta s2. What is the 2 theta? One value we can get minus 45 degree. So what is the theta s1? Minus 22.5. That is the one value. That is the one value, right? What is the next value? What is the next value we have? See, one value we got to know that it is in the clockwise directions. Other value what? The angle between these two particular things has to be 90 degree. Whatever the angle between these planes, that has to be what? That has to be 90 degree with each other, right? So if I'll show one plane, which is defined at an angle what? Minus 22.5, right? So it is going to be something like this. This plane will be something like this, right? One plane will be like this. One plane will be something like this, because axis is making an angle what? Theta in the clockwise directions. From the vertical it is making an angle what? From the vertical it is making an angle what? From the vertical it is making an angle what? Theta again clockwise. So that is the one value you are looking right now, 22.5 degree. 22.5 degree. This is the one plane we got. Now to complete the element, we should have that one more plane. We should be knowing one more plane. And what is the angle between these two planes? What is the angle between these two planes? 90 degree. There is no doubt in that. So one value theta s2 will be what? Theta s1 plus 90 degree. So what about theta s2? Minus 22.5 plus 90 degree. Then what about theta s2? 67.5 degree, that is in the anti-clockwise direction, as you can see from the figure also. This particular plane, this plane I'm calling this to be AB plane. This is for AB plane, and let me call this to be AC plane. This is to be AC plane. So as you can see very clearly that onto the plane AB there will be some value of the shear stress, and onto the AC plane there will be some maximum shear stress, but the values of the angle will be different. One is making an angle what? Positive 67.5, or axis is making an angle what? Anti-clockwise 67.5 degree. Right? So these are the basically the things that we must understand. From the trigonometric, you're gonna get the two values. One will be see, you know that tan 2 theta is gonna have the two values. What will be the negative value? Negative value, everybody know that, where it will be there. In the second coordinate, we also have the negative value. Tan 135 is what? When you calculate tan 135, what is the value? -1. And again, you calculate tan minus 45, again -1. So you got two values. So by using the concept of this one, or by using the trigonometric, you will be getting the answer. Positive means anti-clockwise. Negative means clockwise. The plane should make an angle clockwise from the vertical, or axis should make an angle what? Clockwise from the horizontal. In the course, you will understand each and everything. For the time being, I'm just telling you for the reference point of view, so that you can understand very quickly, right? So as you can see in the option, there is a no 67.5 degree. So only D option will be correct, right? There is only one confusion you might be having, that so maximum shear stress we have defined, that plane we have defined from the vertical, but they are asking with respect to x-axis. They are asking with respect to x-axis. There's no doubt in that. We can able to find with respect to x-axis also. Let me show that. See, AB plane you are looking right now is basically making an angle what? 22.5 degree, or can I say that it is making an angle what? 67.5 degree from the horizontal x-axis? From the horizontal x-axis, correct. What about AC plane, sir? When you consider AC plane, it is making an angle what? 67.5 degree. So can I say from the horizontal, it is making an angle what? 22.5 degree. They have not asked actually what is the plane locations by showing the four option by figure. They simply ask us the value. The value will be what? Minus 22.5 degree from the horizontal or from the vertical. If they would have asked about the plane, in that case, we would say about the answers, right? But that is the orientation of the plane. There is a choice of different candidates. So definitely they will gonna ask only the values, and the values will be minus 22.5 degree, right? Either you can define like this, or you can define like this. The value will be minus 22.5, because with respect to horizontal also it is making what? Clockwise. Remember, clockwise will be negative. That is against our notations, what we have seen in our derivations. If I just again I will just take you back to the what we have the figure, you will come to know theta anti-clockwise, or axis is making an angle what? Theta, right? So these are the notation that we must able to follow. There should not be any doubt, right? Let's see one or two questions so we can solve this, we can get the grip on this particular topic. As you can see, my different this particular figure, they have subjected to sigma xx, and they have been subjected to sigma yy, and they have given tau xy, that is positive value. What is the meaning of positive? They might be showing something like that, right? They are asking what is the normal stress on a plane which is inclined at an angle 45. It is showing at an angle 45 from the horizontal, but I told you in our case we have to define our plane at an angle what? Theta from here, and this is 45. From the trigonometric we know that theta will be plus 45. Once we know the theta will be plus 45, once we know theta will be plus 45, and what is the formula we have to use? A simple formula that we have derived, sigma x plus sigma y by 2. See, we are writing sigma x, automatically that will become what? Sigma xx only. Normal stress notation is what? Sigma. Sometime in gate examination they might be showing you tau xx also. There's no doubt in that. That is also equal to what? Sigma xx only, because you can see very clearly based on the direction. This is the phase, this is the directions. That means if there is a plane like this, if I say this is the plane AB, if there is a tau xx, x phase x direction, that means it is normal to the plane. Automatically it will become what? Normal stress, not the shear stress, right? Now do not confuse. Why why tau xy is shear stress? X phase y direction, that means it is a parallel to the cross sections, as you can see very clearly. Now sigma x plus sigma y by 2, sigma x minus sigma y by 2 cos 2 theta plus tau xy into sine 2 theta. When you put sigma xx, that is positive 110 30 by 2 110 minus 30 by 2 cos 90 degree tau xy plus 40 sine 90 degree. This will be 0. What about the values? 130 plus 110 plus 30 divided by 2, that is a 70 plus 40. So you'll be getting what? 110 megapascal, right? So these are the basically the questions that we must be able to understand regarding the principal stress and strain, right? So more questions we're gonna see that, you know, these are the pattern of the questions. You know, while looking this question, it might be thinking that it will take too much time, but it is not like that. It's a very simple and easy problem you can do, you know. Now just observe the questions and try to solve it. For the state of stress as shown in the figure, which of the following represent the correct free body diagram showing the maximum shear stress and associated normal stress? Right. So one of the very important questions, one of the important gate PYQ problem. See, try understanding. Again, it is a very easy one. First of all, we need to find tau s theta. For tau s theta, for maximum tau s, for T maximum plane, for T maximum plane, we must be able to understand what is the location of the plane. For the location of plane, we know that tan 2 theta, that is nothing but what? Sigma y minus sigma x divided by 2 tau xy. What about sigma y, my dear friend? 12 minus 18 divided by 2 tau xy. All are according to our sign convention, so there should not be any doubt. So minus 6 divided by 8, so you'll be getting what? Minus 3 by 4. So again, you're gonna get the two values. One will be theta 1. If you just take the tan inverse of basically 3 by 4, you will be getting what? Something like a minus 18.4 degree. One value, that means clockwise. From the vertical, from the axis of the plane, from the horizontal, clockwise. Other value you can able to calculate. If one value will be 18.4 degree clockwise, or from the vertical clockwise, other value has to be what? With the 90 degree. With the 90 degree. That means what should be the values? They should make a plane with each other's what? This particular value will be what? What about this angle? 90 minus 18.4, right? So theta s2 will be, this is theta s1. Theta s2 will be what? What is the theta s1? Theta s2, plane of what? Maximum shear stress plane, right? Theta s2 will be what? 90 minus 18.4. And if you just calculate, you'll be getting what? 71.6. 71.6 degree, right? Or you can do that tan inverse of what? 180 minus this. What is the 180 minus basically 18.4? So you'll be getting what? 18.4 into 2, that is 36.8. See, tan inverse of 2 theta is what? Minus 3 by 4. You're going to get the two values. One will be 18.4. Sorry. 2 theta will be what? 36.4. You only calculate from the calculator. There's no confusion. 36.87, one value. And 180 minus theta is also 10 minus 2 theta. 180 minus 2 theta, that is also minus 10 2 theta. Right? Now, so what is the 180 minus 36.87? So you'll be getting tan 143 minus something like that. So tan 143.13. If 2 theta value is something like that, 2 theta 1 s1 is minus 36.87. 2 theta s2 is what? 143.13. So theta s1 will be what? Minus 18.4. and theta S2 will be what? 71.6 degree. What is my point? So it's a very simple. Either you can do both the planes should be perpendicular to each other, both the planes should be perpendicular to each other, or by trigonometric. Anyway, you will be getting the answer exactly the same. So that is what we got the answer. That is what we got the answer. That means a plane should incline at an angle what? Minus 45 degree. That plane orientation should be something like this. So definitely this option will be disregarded. This option will be disregarded. As you can see that this plane is making what? 18.4 degree in the counterclockwise. That is not correct. Option B can be correct. Option C can be correct. Option D can be correct based on the orientations. Now it's a game of what? Tau is theta. Just find the tau is theta, my dear friend, on this plane. Let me call this to be AB plane. Let me call AB plane. AB plane. AB plane. I have defined AB plane in all the three options. Let's see. Sigma x minus sigma y by 2. What is that value? We have the formula sin 2 theta minus tau xy into cos 2 theta. Put the value. What you are getting? Sigma x is what? Sigma x, my dear friend, what you are getting? 18 minus 12 divided by 2 sine theta. What is the value of theta? For the plane AB, the values of the theta is what? Minus 18.4. Not plus, minus, right? It is making an angle what? Clockwise. Clockwise. From the vertical or axis is from the horizontal, right? So now, so sine minus of 18.4 into 2. Tau xy is what? Positive. Cos 2 minus 18.4. So my dear friend, what you are understanding from here, if you just calculate tau is theta, you will be getting the answer as minus 5 megapascal. What is the meaning of minus 5 megapascal? My dear friend, we have defined our plane. Okay, we have defined, see, we have basically, where I can just write, I can write over here. Try understanding what I'm saying. We have said that we have defined one plane at an angle theta from the vertical when tau is theta is acting like this. When tau is theta is acting like this, that means it is a positive. If tau is theta is acting like this, it will become a positive. That means if this will be my x1, original my x is like this, my y is like this. When I tilted in the clockwise, anti-clockwise direction, this will become my what? Y1, and this will become my what? X1. And what you're understanding, my dear friend, that tau is theta is acting opposite of y1 axis, and that is a positive. That means what you are understanding, if I tilted my diagram, this will become x1 and this will become my y1 for the plane AB. This will be new coordinate axis, and that is what we are calling principal stress chapter to be whatever the equation you are seeing, these equations, this equation to be called as transformation equation, because we are transforming our axis from x and y to x1 and y1, right? This x and y we are transforming to this plane, something like this, x1 or y1. This transformation we are doing by with the help of what? Whatever the equation we have developed by using the what? Principal stress chapter. And what you are understanding right now, tau is theta is negative. That means it has to be in the same direction as y1. Tau is theta. That's it. We got the answer. No need to look at any option right now. You can see that. Why? Because if one we got the arrow, other arrow will be automatically adjusted like this. Because these are the complementary shear stresses, my dear friend. These are the complementary shear stresses of equal magnitude. So only which option is satisfying? B option as well as C option, right? As you can see that B option is satisfying and C option is also satisfying. D option will be disregarded because direction they have shown what? Like this. That is incorrect. Now we need to find the normal stress onto the plane AB. So what is the normal stress formula we can have? If I just remove this part. So these are some of the good level problems that has been asked in previous year GATE Aerospace. Now, so if I'll be just saying sigma n AB on a plane theta which is being inclined at an angle what? Minus 18.4 degree. What is that formula? Everybody know that. Sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy into sin 2 theta, sin 2 theta. When you just put the values, tan of minus 18.4, something, theta will be minus 18.4 and sigma x and sigma y, you will be getting sigma ns plus 15 megapascal. Plus means away from the cross sections. Option B will be correct. Right. So more detailing of principal stress and this particular basic fundamental of basic elasticity will be covered in our basically crash course in a beautiful manner. These are some of the glimpses that you can understand the concept of what principal stress. And again, that will be just like a reason for us, So thank you guys.